Hey!
Example 6, last example. Let's solve the system graphically.
Graphically.
So we have to, in order to put these in our graphing calculator, solve for y.
Unless you have an Inspire.
For Inspire, you don't have to?
I believe Inspire. I'll just double check real quick.
Okay, well, I'll get started on solving for y. On this first one, we start off by subtracting x squared. So y squared equals 9 minus x squared. To get rid of the squared, we square root both sides, but this is the tricky part. You have to...
Plus or minus that sucker, or you'll be in trouble.
Right, which means when you type this into your calculator, you're going to have y1 equal, and you're going to put nothing, square root 9 minus x squared. For y2, you'd have to put negative square root of 9 minus x squared.
Look at that. You
when
can
you graph just
do a circle.
How did you do that?
You just go into menu and choose function.
And then you backed out of the y equals?
Yeah, and it takes it out of y equals. I'll put a video up later.
Okay. So, but for 84s and 83s, this is the way to go, is to solve for y, and you'll have two entries. This is a circle, by the way, with a radius, nice, of 3. Okay, that's what's happening here. The second one is a line, so we'll have to solve for y. Divide by -6.
The beautiful thing about this is, if you're going to solve this on your calculator, no matter which calculator you use, you don't necessarily need to reduce everything down. Like, for example, Mrs. Stevenson right here, she could have just left it.
Yeah, yes. That's true. But my,
But she's so brilliant that it just naturally occurs to her.
I was going to go OCD mathematically.
I was going to go with brilliant. Sounds math OCD, yeah.
So these three things we'd put into our calculator, and so if you do that, it should look something like this.
Wow, where'd that picture come from?
It appeared as if from nowhere.
It did?
Yeah, it's pretty cool. So the x squared plus y squared equals 9 is this circle with a radius of 3. Here's our line that goes through that. And here are 2 points right here. Those are the intersections. And so on your calculator, remember to find points of intersection, you do
second trace,
which is the calc menu. And you go down to intersect. And with this situation, it's kind of tricky because both of these are going to be on the bottom part of your graph.
I believe so,
the
yes.
y2. Mm-hmm. And so whenever it asks you like first curve, second curve, you need to make the first curve be the bottom. And you do that by
up and down
arrows. So this can be kind of tricky. This one you should be able to like eyeball pretty easily. The 3, 0, it may give you issues if you try to do the intersection.
It might, but I think it'll be okay.
But this one right here, as long as you pick the bottom part of the circle and the line, it should give you, and then go close to this dot whenever it asks you to guess, should give you that one pretty easily. So those are our 2 answers right here.
Yeah, right. What?
Right there.
What?
I don't know what happened.
What happened on that?
That I don't know.
Okay.
There are some word problems in this section. I know that there's one that talks about perimeter. Remember that perimeter is 2 width plus 2 length, right? An area, and we're talking about a rectangle.
Rectangles, yes.
And the area of a rectangle then would be length times width.
Right.
If depending on what information they give us, we potentially have a system of equations here.
Right.
So
and maybe both of those could come up at the same time, potentially.
Right. Yeah. So you'd solve one of them for like say W, plug it into the other one, and in general, I feel like I find it easier to solve this one for W or L and plug it in here, then you've got a nice polynomial.
Right.
If you do it the other way around, you end up with
you could end up with some really weird stuff. Yeah.
Thing. So that's all we have for you.
There you go. Code word, by the way. Let's go code word for the day. We got a good idea?
Bananas.
All right.
Code word today is bananas.
All right.